So, Tomas, it looks like Tyler is set to be our main first topic, and I don't see them having joined yet. Do you know if that was confirmed for today?
Right. So Peter is unfortunately unwell, so we had to reschedule his talk in a couple of weeks. But Tyler is in principle going to join because, well, let me see if I can reach out to him.
Okay.
No answer from him. Maybe Usama, you had a couple of oh, he said yes. You had a couple of points, right? So if you want to bring those up.
Yeah, sure. So I can start. So so the first one was there is a pending PR regarding the adding on the list of the approved project. So it was approved and it's not yet in the list. I just saw that it needs to be done. It's pending for a couple of months now.
All right, sorry.
This is an action for the chairs. So please do it soon. And the second one was we talked about in I think month before about the funding for SIG, and I wanted to ask if there was any update on that from the chairs or from Fritz or
I think Sal had an action on this, right? But
yeah, she
he's
said
only now, so I'm not sure. And I haven't heard from.
So I postponed, or I heard Sal wanted to take over that, so I didn't take anything there anymore. If there's no updates on that front by next meeting from Sal, we can, or I can pick it up again, but I didn't want to interfere with something that's already going on.
Okay. Right, thanks. And third thing in the list was I have a couple of slides which I will just quickly show. Some of you maybe already know this, so so the idea is basically to have a common understanding of the different standards which are using attestation in their definitions, and this is something which I have or rather we have along with the same people that I presented last time. So basically we have tried to cover the main spectrum where attestation is used, and it's supposed to be discussed with the SIG. Like, of course, like attestation is interesting for all of the SIG because it's attestation SIG. So the idea here is that I would like to do a kind of a survey on the different use cases of attestation within the scope of confidential computing specifically. And I would like to discuss a little, or to let's say to ask the SIG what would be more interesting, of course, to limit the kind of the scope of what we focus on. So it will be nothing about formal verification, nothing about formal specification even, So we will be just trying to figure out some common definitions that we will base, of course, on some of these standards like IETF or DMTF, and there are plenty of others like PCG, Global Platform, ETSI, 3GPP, and so on. So we will try to figure out how we use, because there are also some networking use cases which are using confidential computing, and I had a discussion with one of them, and they have very confusion in understanding what a relay party is and how these terminologies are defined in the IETF RATS architecture. So the idea here was that we have somehow discussed a lot about this side, which is the secure channel establishment. We have one project on this side, which is this COCO KBS, from formal specification or verification perspective. And somewhere in between is somehow unknown to us, or let's say its ad hoc protocol is also formally specified. And there is a proposal also in the IETF, that's why I show here as blue. So they, just like the tested TLS project that we have, similar to this ad hoc in the Lake Working Group, they are trying to use attestation for the ad hoc protocol. And SPDM by default has its attestation inside, typically for device level. But I have seen from my analysis that also it is, at least one of the work is also using it over the network. It's not actually meant to be for that, but it's still being used for that, or proposed to be used for that. Anyway, coming back to this TLS side, we had the three, the nice division of pre, post, and intra kind of thing. Intel's RATLS is the pre one, this is post, and in between we have the IETF draft, which is describing the intra, and also SCOAN lies on this side, which is the post handshake attestation. So yeah, so this is open for discussion. That so there are a lot of things, like, I mean, this is the second slide that I wanted to show. So there are different network levels at which we can visualize attestation being used, and of course a lot of scope can be covered, but the point is that what would be most interesting for the SIG itself to that's it. So I just wanted to present the 2 slides to start the discussion and to see what would be useful for the SIG to discuss.
So just to make sure I follow, like the title of the slide is use cases of attestation, but it seems like it's really outlining the different solutions and how they address where they inject attestation more than it is the actual use cases, right? Is that what you're wanting to focus in on, is
Yeah.
where the attestation is injected into the communication?
Yeah, I think the title is not really descriptive. I agree with you. So it's not really use case in that sense. So it's in the sense of how primarily I can use it. Here it's used for secure channel establishment, establishing a channel between 2 entities, and here it's used kind of for the issuance of the credential, more on the authorization side kind of.
Mm-hmm.
And in the last month, like, we had a lot of discussion there was a hackathon in Paris on the Lake Working Group ad hoc folks. So basically we were discussing what exactly is the difference between authentication and authorization. And today morning in the WIMSE group, I have seen a similar email like describing the ambiguities in the WIMSE architecture on the exact same point. So I think there is a lot still unclear about all of these things, where exactly the boundaries lie, how to use that, and how to properly visualize them, and how even they are defined in these architecture documents.
Makes sense.
How do you want to proceed, Usama?
So I would first like to have just, of course, I know the formal steps to proceed. I have already a couple of accepted projects, but particularly now I would like to have some discussion around, or not necessarily now, so because Peter was sick, so I just thought that I can put it up now. I would like to have some feedback on what would be interesting for the group, what areas we can focus on for this scope, and hopefully I would like some participation from all of the members of the group to, as I said, it's nothing about formal verification. We just want to, as Keith said, how and where attestation can be injected into the different protocol layers, and maybe to give some recommendations of where to use it and where to not use it, and what are the kind of privacy and security concerns of using it in different ways, and so on.
I suggest you find
I,
it and add the sort of desiderata there, some material that we can discuss already, and then notify the Slack channel, and we can move.
So say again, Thomas, I didn't follow. So you were saying to
File an issue.
put something?
My suggestion is to file an issue to
Mhm.
try and sort of articulate a bit more the idea, present some of the material that you have here, and just restate the problem that you want to solve, and then
So
maybe
the problem in that approach, sorry, the problem in that approach is it's very wide project. So it's the idea of a little bit of a discussion was to maybe narrow the scope already, because there's a huge use of attestation, and
yeah, I mean we can work on narrowing the thing on the issue, can't we?
okay, on the issue. Okay, right. That's also fine. Okay. Mhm.
As you say, this is not the time, probably because we have Tyler and he's-
Okay, so he's in. Okay, okay, all right.
Either we
Yeah.
reschedule that, but I suggest you just file the issue so we can start the conversation.
Okay, okay. If somebody has any quick comments, so maybe we can take that. Greg wanted to say something, probably.
it's a quick comment. So is the text in the meeting notes says, you're thinking about a survey of,
Yeah.
elements in the space. And then at a high level, I can conceive of, surveying, emerging standards and specifications. I can also think of surveying implementations and particular technologies. As you say, this is super broad, and I think to help focus it, we can't boil the ocean, or we shouldn't attempt to. I don't think so. Figuring out how to narrow it down, and I could imagine pivoting on some of those categories. Is it a survey or not a survey? Is it focusing on standards, or is it focusing on implementations?
Mhm.
And I think, as Thomas said, what's the problem? And whittling it down to kind of one, is to begin with, right? So is it to help establish a common nomenclature for standards writers? Is it to help to establish, common nomenclature for the implementers, or what have you? But it's even I think it's super valuable. Even just looking at the couple of slides you had, it got me already thinking about things a bit differently. So I'm enthused about discussions in the space, but somehow getting it narrower and focused to like Thomas said, on a problem or something, or or a subset of the space standards or implementations or something.
Right, sure. Yeah, thanks a lot. Okay, then I will stop sharing.
Thanks, Usama.
Thanks a lot.
So Tyler, if you are ready. So Tyler Fanelli from Red Hat is going to give us a deep dive into an attestation server that he built to support the KRAN based confidential containers. And for those who don't know, KRAN, it's an extension to CRAN that allows running containerized workloads within a micro VM, sort of the inverse of Coco and Kata in a way. Tyler made a presentation at the TAC, I think back in April, of KRAN. And that thing is recorded, and if you're curious about the background, I can add a pointer to the minutes, and I just need to dig it up. But I would leave the floor to Tyler. So just one question, Tyler. How do you want to take the questions, as we go, or at the end?
I was originally planning. Can you hear me all right?
Yeah, we can hear you.
So I was originally planning at the end, but however, if anybody wants to interrupt me, it's no problem whatsoever. Just stop me, and if there's something not clear, I can clear it up during the presentation.
Thanks.
Is everybody just able to see my screen all right?
Yeah.
Okay. So yeah, it was originally going to be a technical deep dive. However, I for the sake of time, going to keep it about 20 minutes. I've just gone into the bulk of the difference between Keybroker and what traditional servers like Coco KBS do, and how we're trying to actually integrate the two. So just as I was introduced by Thomas, I'm Tyler. And I'll just be talking about how we're attesting containers with Keybroker, and I'll also give you a bit of a background on how we're using this technology. So just to start, for background purposes, he mentioned the Krun container runtime. Basically, that's just an extension of the crun runtime with added virtualization. It runs your containers inside what are known as micro VMs, and they're optimized for boot time and memory footprint. You may have heard this in the QEMU micro VM machine type is just kind of an offset of that as well. And what they basically provide you with is a smaller memory footprint than standard VMs. Just wrapping the container workload with minimal amount of devices. And we recently added SEV SMP support with Attestation. So we're going to talk about how we built a server to kind of work with that. And what is Keybroker? It's a simplified attestation server that reuses the KBS protocol found in Trusty, formerly Coco KBS. So much so that they're starting to converge the similarities so much that I'm experimenting with Keybroker usage of as the attestation service. Also, you can kind of think of that as the back end of the Trusty attestation server, instead of its own standalone thing. But it's just something that would live in the back end of Trusty. And Keybroker follows RATs, and there's a few modifications around registration and handling of reference values needed for running confidential container images as we build them. So, and I'll go into that a bit more now. So, if we think about container images for confidential computing, we know that users want confidence that their workloads are running confidentially. And we were wondering if it was possible to force attestation within a container image. If it was possible to do that, if it was possible to build container images specifically with confidential computing in mind, such that a container image that you would like to run cannot be run unless you attest it on some type of TE hardware. So if it was possible to build container images such that attestation is required for running it. And if we were also wondering if can we leverage existing container image builders to create images for confidential computing, such that they can live on some registry somewhere, but in order to run them, need to be attested. And of course, we'd like to make this simple as possible and hide as many details as possible that you're running. It's actually built for confidential computing. So a component we use for that is builda. There's two new subcommands for builda, sort of basically the builda build subcommand. That includes a new flag called CW, which stands for confidential workload, to build OCI images with Krun attestation in mind and forces it. And I'll go into a bit more details on how we do that. And there's also a subcommand make CW, which takes an existing container image and converts it into a confidential workload image. Both of these commands build what we call confidential workload images, and they register build information with an attestation server at container build time. So when you're creating this image to be run. So you create one image, you can reuse that image to run, but everything that's done at build time is registered with an attestation server, and attestation is required in order to run it. What do I mean by that is that what a confidential workload image actually is. And right now it's only expected to be run with the Krun runtime. However, there are other runtimes that could implement it. And there's essentially two main disks expected in that image format. Is that there's a root disk, which contains everything that's going to run that workload. It contains the application code and data, and that's LUKS encrypted. And at build time, it's LUKS encrypted, and the key is stored on an attestation server. So like I said before, we build the images once. You can reuse this image, but in order to unlock that root disk and begin running, the key is actually stored on an attestation server somewhere, and you would need to contact that attestation server, do an attestation, and to get that key in order to run. So that's the root disk. That's essentially what everything you want to run and what's encrypted. And then there's one data disk that contains all the data needed for attestation, such as the URL, the attestation server needing to communicate with. And because sorry, somebody say something?
Oh. Yeah, I was speaking out of turn, then I realized I have to raise my hand, but so fascinating functionality. I'm really excited to starting to appear. I do have a question, however. If I have a high availability application, I need to roll an upgrade, which means that I have to put a policy on attestation server saying, okay, start recognizing this image as valid. But for a little while, I also need to keep the older image around while I'm doing the rollout and perhaps even do a rollback. How do you see that kind of orchestration taking place? Sorry, are you muted? Because I can't hear you.
Tyler, you there? Mark, you killed him. What's happened?
So sorry that I know it was a difficult question, but
There's update and live migrations. Those are two difficult questions. You can ask them. People will just trip on them. But you live migrate the container.
He said he may have dropped rejoining, but I see him there. So
Hey Mark, are you thinking about the policy enforced on what's here called the attestation server for releasing the key for decryption?
yes, I'm talking about specifically the intermediate state where you have both old and new valid, which is very common in high availability orchestration. So what they're doing is
trying to tease
absolutely
out.
necessary.
I mean, there's a lot of engineering to do that has nothing to do with attestation and running confidentially. And then there's in the picture here, then there's the part that seems unique to running confidentiality or running in these confidential environments is the process for releasing the keys for decrypting this container here would have to be aware of essentially, two modes. You're running you only are expecting one container image to run, or during a transition period, you're expecting and allowing two. That seems to be the delta from just being able to handle that scenario, nothing to do with confidential containers. So I'm assuming that's the part you're focusing in on.
I mean, it does matter insofar as ability to utilize the technology to actually do real world orchestration. So I'm just curious how you see this addressed, just a higher level construct.
Well, it's absolutely a real world scenario that as far as this conversation is going, the part that seems important is anything to do with the confidentiality of the containers and the securing of the containers using TE technology. And yeah, your question makes total sense.
Okay,
Tyler back.
Sorry, question. Service question. Is there anyone that is admin on this call that can remove the screen sharing from Tyler? From Tyler number one.
Sorry about that. I think I dropped there, and the old user there. I can't share my screen now because of it. Sorry about that. If there's an admin that can kick somebody, kick the user with my name that's sharing the screen, so I can share again. I hope.
I don't appear to have that.
Me neither.
Oh boy.
Not sure who's admin.
Same here, not me.
Yeah, I think before they transitioned over to the new Linux Foundation-based Zoom, the chairs were all given admin, but it doesn't look like that carried over to the new system.
Oh boy, yeah, I'm unable to share because of that now.
Oh gosh. We're stuck. And we all log out and log back in, we will find the old Tyler there. So,
Oh, there it goes. It just dropped.
ah,
Okay.
awesome.
Wonderful. And I can share now. As I heard from, it seemed to be explained pretty well. Is we're just essentially reusing the Lux encryption in order to actually be able to run, you would just have to attest with a server, and so you could reuse the same container image. It would just every time you would actually need to run it, it would need to be attested. And I'll come back here.
My understanding is that Lux keys are protected by the TPM, so you would need to have sealed NV data for your TPM. But as far as I know, there's only ephemeral TPM technology supported in confidential service modules like Coconut, SVSM, and Microsoft's HCL.
This isn't expected. There's no SVSM running in the guest at this point. There's no VTPM needed for this, because it's just essentially with the Krun runtime, what it's essentially targeting was running processes virtualized. And it's instead of, if you can think of with the micro VM point, is that instead of full VM workloads, essentially, short lasting processes that need to just be run and then go. And then inside the guest, there is no VTPM required. So we store that Lux encryption key on the server so the image itself can be reused. Does that make sense?
Is the key wrapped to the VM before it's transmitted?
The root disk is encrypted with that key, and then that key is just sent. So you essentially, when you're building this container, you would need to trust who's building it, and then you would need to trust that the attestation server is correct and who you're talking to, and the correct one that's going to be reached out to. We associate an ID with that workload in that attestation server, so the image itself, and that image, that ID that I'm talking about, is buried into the data disk. Like I said, that contains information that's needed for attestation. Part of that is the URL of the attestation server. Part of that is an ID associated with that workload. So you can kind of submit your own policies. You can submit your own reference values instead of having to trust a global attestation, which I'll go into in a bit there. But it's all stored on the server instead, and the guest has no need for a TPM at that point.
But
So I'm sorry.
When the key that encrypts the disk is released from the attestation server to the machine that's going to run the container, the environment that gets that key is a TEE secured environment, and I'm assuming it just uses the key to decrypt. From its perspective, it's ephemeral. It doesn't need to persist it. It uses it to decrypt the disk, and then the container's running, and it can forget about it. But when the container's relaunched, it has to do the dance again. There's no persistence on the side that runs the container. It just uses the key keeps it in memory or whatever, and it uses it, for one container session. And if there's a new launch of a container, it has to do the dance again.
That's right.
Okay?
Every time you would relaunch this container, you would need to attest. So if you're running it multiple times, it would need to do a new attestation every time.
Yeah. And part of the whole attestation process ensures that the environment that the key is released into is a TE secured environment, so
that's right.
Through that,
So
examination.
The one problem we had with keys is that we didn't want something like a replay attack to be able to happen, and you get somebody who's not supposed to get access to the key does. So if you've successfully attested, you also give over a public key to encrypt that deluxe encryption passphrase with. So that key can be reused.
Do you have pre-established credentials to talk to your attestation server, or is it all part of the attestation dance?
Can you repeat that one more time?
Do you have pre-established credentials to establish a non-attested connection to your attestation server before you send an attestation report, or is the connection through an attested channel like ATLS?
Neither of those right now, and one of those would have to be established in order to the correct people are talking to the server. Right now, we just kind of you reach out with some ID that you registered beforehand within the image, and the attestation takes place. This is still under development, so something like that, to control who can actually reach out to the server in the first place, would need to take place.
Sorry,
can you?
One question. Oh, sorry.
Can you describe the policy that's used in the attestation server to release the key?
So I can, and let me, at later slides, it goes into that.
Okay, then.
The thing is, the one thing about this is that it's up to the guest itself. The guest can define their own policy that they want to attest with that image. And
I'll wait for the next slide.
Sure. And Daniel asked, is attestation used to get the Lux key? Basically, yes, to unlock that workload. Mohammed, did you have a question?
Yeah, so I want to get an idea of when exactly is the attestation formed. Like we discussed, like pre-handshake attestation, post and intra. I believe what you are saying is kind of a post. Is it correct?
It is. It's done within. So we have the K-run container runtime. What that essentially does is it spins up a VM. And one thing that we buried kind of into the firmware is that there must be an init binary run before your workload runs. What the purpose of that init binary is to do the attestation itself and unlock the root disk. So there's, this is all done within the K-run container runtime. If I had more time, I could go into that, but it's kind of hand wavy at the moment that it must. It all happens into the runtime itself to unlock that root disk, and then it can just exec into it.
Right. So but the overall idea is that basically you establish TLS connection first and then send the evidence, right?
So as we don't do TLS at the moment, however, it would need to, yes, at some point with later development, it would need to start the TLS connections from the guest first.
Okay.
And establish some type of credentials or establish some type of identity as well. All right, I can continue on then. Now that we kind of have an understanding of what the container confidential workload image is and what we're trying to do with those images, we can, I've gone into this already, but that at Builda's container image build time, Builda would measure each VM component that's going to be used to run the workload, such as the qboot, the kernel that's going to run the init RD, and computes the expected launch measurement. And you can also submit, I didn't go into it in the slide, but you can also submit a policy with all your reference values that you're going to submit with Builda. You could submit a policy that's going to register itself with the attestation server. And then all information that's needed for the guest to attest, like I said before, the URL is going to insert it into the data disk itself. An important note of this is that all of the registration of reference values and any other data needed for attestation is done at container image build time, such that any user of the image must attest with the attestation server that the image was built to attest with, and whoever runs the image must attest it. So we register some information at container image build time. And one problem that we had with, if we think about a traditional RAD server approach, is that there's global attestation policies that apply to every client that's going to attest. And evidence has to be presented in a format that the attestation policy can interpret, and all the reference values must be submitted at one point. So it's one global attestation policy that applies to all clients attesting. One issue with that is that we don't know the reference values. It's up to the user to define them when they build the container image. So we can't define one global attestation policy. We kind of have to make it with a bit more granularity, that they can allow a user to define its own reference values, define its own policy, and submit them at build time. So we need something a bit more flexible. Because when we're building container image, the essential use case here is that we'd like to just run an attestation server, begin building container images that are going to be used, that are going to be required to attest with in that attestation server, and then start running them with the krun runtime, pointing it to the correct attestation server. And with that, because you give users the freedom to define their own reference values and whatever policy they want in order to run, it's kind of all those reference values and policies are workload specific, and they're not generated until build time. So we don't know them beforehand is the essential gist here, in that we required something a bit more flexible. So the main differences with Keybroker is in the registration interface. The Keybroker maintains a registration endpoint that handles post requests to register clients for later attestation. So something like Builda can reach out to the register endpoint, can register and say, here's my reference values, here's my policy, the expected launch measurement, what architecture I'm running on, and you would have to attest accordingly. What Keybroker basically does there is it generates a UUID and stores all of this reference value information into a map, and then returns that UUID back to Builda or whatever management application you're using to build these images. So it's essentially personalizing a bit more of the policy. And that, I think that goes back to a question I just had on who's defining the policy, somebody asked. We're really leaving that up to the user, and they store all policies and reference values in a map, so such that when they come to a test later on, they can do so. Does that answer the question I had earlier? I forget who asked it.
Yeah, I think it was me, and I'm just, so I think what I'm catching here is at build time, you create your image and then you encrypt it against, it sounds like a single key that's maintained by the KBS server. And then you register, your build essentially using this API here, and you're going to pass up, you can pass up some reference values, which I think boil down to hashes for your container, and then some policy. And it's not unclear to me. I mean, what I'm really fishing for here is who's allowed to get the key to decrypt the container. So who makes the choice, like, oh, it must be a TE protected environment, and it's cool if it's TDX, but not SEV-SMP, or SEV-SMP, and I'm okay running slight little firmware or something like that. Is that what the policy is intended to be, or? That's
right. Yes, that's all defined within the policy itself. So you can define, yes, we can only run on this TE architecture. If we're running on SEV-SMP, it has to be this firmware major version with this firmware minor version at least. The launch measurement has to include, it has to be this or something at the moment. And it's a tough thing explaining policies, because it's really up to you. One thing we explained, we could write the policy in OPA format and basically run an OPA interpreter on top of that, as long as we supply the reference values and all the data parsed from the attestation report. It's really up to you at that point. You build an OPA policy to make it as restrictive or free as you want.
So then where do the reference values from the TE manufacturer come into play? Are you expected to pass them up in your policy, or are they, provided an independent, channel to the KBS server?
Can you define what you mean by reference values of the manufacturer?
Yeah. Let's just say, for example, Intel, SGX, or TDX, right? So they have a service in the cloud that basically says that publishes the current set of trusted firmware and so on for the SGX hardware and TDX hardware. So, so rather than, eventually it boils down to there's got to be some, enforcement saying, make sure that firmware version or SVN level for firmware is greater than or equal to 10. Well, Intel, for example, publishes what they think, believe is correct. And so does that value, like, if all policy is coming from the client here, and if logically the client wants to say, I like, TDX technology and whatever Intel says is trusted firmware, do it, versus, oh, I like TDX, hardware, and I now need to copy and paste all the current trusted firmware versions from the Intel site into my policy, and then update, my policy every month or so when Intel updates. So that's what I'm asking. How does that flow work?
To do the updates, you can revoke policies that are associated with an ID and then resubmit them. Where these values are eventually parsed from right now are kind of constrained to the attestation report. So each, depending on if the attestation report is a set of S&P or if it's TDX, the values are parsed in that report differently. Anything that comes from outside of that would need to be supplied. Like if you have a specific firmware version that Intel publishes or something like that, that would be more on the client side, where you would say, you'd have to go and change your policy and then resubmit it at that point. Pull the policy back and then and say, I'm changing it out for this. So the policy that you associate with this ID needs to be changed to needs to be switched out for this new policy. And that's for anything that comes from outside of the attestation report, though. The attestation report, we have a kind of a format that we deserialize them into, and then you can check that value in the policy.
So so thank you. I think what I'm hearing is there's no channel that's natively built into the KBS server to ingest essentially trusted reference values from the TE hardware vendors, the supply that build the technology. So if these vendors do provide, statements of what's, trusted and what's currently trusted and not trusted, which my understanding is they generally do, it's the responsibility of the client to proxy those values to the KBS server through their policy definition. And I suspect over time that's a challenge for clients to do on their own. That might be kind of a
there would need to be something in place to do that, to automate that process a little bit. I mean, you could use, it's not the place of Builda for checking something like that. It's something that interfaces with Builda to rebuild these images and with what trusted values you would need.
Well, the reason this jumps out at me, because I think what's called the KBS server here in my mind, and how we have things factored in where I work in Azure, is there's two different services. There's a verification service, and then there's a key management service. And the verification service, can take policy from caller, essentially saying this is, what we want to release keys to. But the verification service, has a channel to accept information from the TE vendors, and basically clients can choose to reference that and say, I want my policy to match what the TE vendors are saying, or they can override it with some, deltas that they choose to. And so that's, as I just compare this to, something similar that we've got going in Azure, there is that flow of information from the TE vendors, and I think that Verizon also has a similar flow set up in it as another example of a verification service. You
have multiple supply chain inputs, and you allow them to be orthogonal.
Okay. Yeah, it's a few things. One thing that we're trying to handle is from the supply chain itself, but since everything's kind of only focused within that client, always done it through the client side itself, not the server maintaining some type of trusted values from a supply chain.
Yeah,
it's an interesting proposal,
But
though.
From the TDX perspective, right? Intel publishes reference values, and I think you treat reference values separate from policy. Now, a customer can say my policy is strict, and everything must match the latest reference values. But that is the policy, right? So,
Sure.
so a customer can say a policy is, it must be patched with the latest patches as the vendor, manufacturing vendor says. But typically policy is really the trust. That's what the trust is. I don't require the latest patching, for example, maybe for a certain amount of time, or I've looked at the security vulnerabilities, the SAs associated with whatever patch, and I'm not affected by them. But that's the policy. So the manufacturer publishes the reference value, but the policy makes the trust decision.
I see. Okay.
Yeah, I think the reference values are required to match against the attestation evidence. And so I think, you have the evidence, you have the reference values, and then you have policy about how you want to apply the reference values. And this model, I think it's the only conduit for all of this information is that arrow from the left going into KBS. And
That's right.
And the reference values ultimately are sourced typically by the TE vendor. And but this is
but the one thing we've always said is that you could, as the client yourself, you're making all the decisions, and that you would be responsible to supply those from the supply chain. That was the way we always looked at it. That leave it all up to the client. Don't and let them personalize and make it restrictive and as open as they want. I guess with reference values, that's you can still from something like the manufacturer, you can supply that as well. Like you said, they posted the recommend reference values for firmware and such, so that can change it a little bit.
I totally understand how the system can work, and the registration, the power in what the clients can do is certainly there. So I get that it can work. I'm reflecting out loud how this compares to a diagram where there's more pieces comprising, if we break this into more pieces, how they all interconnect. And so, for example, if KBS server were broken into a verification service and a key management service, and then if perhaps the verification service were enabled to be any verification service or more than one, perhaps a Verizon or a MAA from Microsoft or ITA from Intel or what have you. But I totally get that this can absolutely can function correctly, and it's just who does what, and over time how grumpy they get about what they're doing.
Now, something to give access to supply manufacturer reference values, which are different than what something from a client where you're defining the policy to make it as restrictive as you want. It really has nothing to do with the manufacturer's reference values. So something like that, incorporating that with it, could something worth looking at. And
I suspect if you go down that path, the question to ask might be, do you want to split this up and allow, break it into a verification service, break the verification part out from what you call the attestation server, and then perhaps also answer the question of, do you want to, integrate with other verification services other than the in addition to the one that's currently coded in the attestation server.
Yeah, some of that work, we've had some I've kind of drawn up some proof of concepts to kind of offload the verification or the KBS part from and try to integrate that with Verizon to do the actual to act as the verifier in RATs, which seems like that could be the best route to do for separating that out.
Yeah, I think that's absolutely an example of what I was just talking about there.
Yeah, it was. So when you mentioned that, it sounded exactly what we were trying to do with incorporating Verizon. For the sake of time, I'll just try to finish this real quick with a quick demo. If we want to have some more questions, we can. But as I said before, we register with that ID that maps and sends that back to Builder, and Builder would insert that into the container image data disk. At point of attestation, the confidential guest would present its attestation evidence to the server. Part of that would be the UUID. That we have a format that the krun runtime knows how to build, knows how to serialize all the data into, and then sends that to the KBS server, key broker in this point. Key broker can then parse that UUID from evidence, find the attestation policy tied to that specific guest. Just as the example, we sent UUID 7 back at registration. It parsed the UUID, finds UUID 7 in that map, and uses that attestation policy to then attest. So it also kind of personalizes the attestation to a client, to one specific client, like we've talked about before. Is that clients can define their own policy that they want this container image. If this container image is going to run anywhere, you need to run it with this policy. And because we tie that UUID into the data disk, it can't change. And the data disk also contains the exact attestation server that we've used to attest with. You must use to attest with where all your reference values are. And this is all done through the krun runtime. I wish I could go a bit more in detail. Maybe I can at a later point, but it understands how to speak all of this and reach out to the correct attestation server. This kind of goes into the krun runtime itself, and how you can kind of just be presented a container image, and the krun runtime understands how to attest with that and run it confidentially. So this goes into this. I did this talk at Container Plumbing Day, so it kind of goes into what attestation is. I think I can save this for this audience. It just computes the hardware validation. I give an example with AMD, software validation with expected measurements, and then you can also define this in your policy. And on a successful attestation, we return the LUX passphrase back from the attestation server. That top one should say krun VM, not attestation server, sorry. And you can use that LUX passphrase to unlock the root disk. Once it unlocks the root disk, it can begin running as normal. And that's running confidentially on the system. I'll stop sharing now, and I'll give one very quick demo on just doing this from the command line. Samuel, do you have a question before I go?
Yeah, just to repeat what Diona was asking on the chat. You confirmed that there is no single key. There's one key that is shared so only one key per container image, right?
That's right.
So you don't generate a new key every time you build a container image from different tenant. So you would distribute this container image, and everyone running this container image on a tested guest would get the passphrase back.
That's right.
Okay.
Yes, every time it's randomly generated at build time. So
Sure.
If you rebuild the same image, you're going to have different LUX passphrase. I'm just making sure I understand you correctly. I don't think that's what you were asking, but I'm just saying if you rebuild the very same container image, you're going to get a different.
Yeah,
it's randomly. But as long as you reuse that container image, yes, it's
for every build of the container, you would get a different passphrase. But anyone pulling this image into an attested guest would basically get the same LUX passphrase back.
That's right.
Okay. Thanks.
And just a quick command line demo real quick for the sake of time. Let me share my. Everybody able to see that all right?
Yes, I see it.
Okay, great. So on the, I'll just kind of go through what we have here. On the bottom left here, we just have a regular Go web server. And if you see the passphrase there, in hello handler function, the passphrase is open sesame. That's basically our plain text secret that we're going to be running in a confidential VM. So basically if we dump the contents from the host, we won't be able to see that secret. If we are running unencrypted, then we will be able to see it stored in plain text memory. And real quick, so this is the absolute simplest OPA policy, is that we're just going to check the launch measurements. The input measurement is data.measurement is the reference values launch measurement that we found, the expected one built at build time. And the input measurement is what's parsed from the attestation report. And all we're saying with this policy is make sure that those two are equal. Anything to do with hardware validation, tracing some certificate chain, that's done regardless of the policy. You want to check that your attestation report is, of course, authentic, no matter what architecture you're running on. So that's kind of a given. You don't need to specify that within the policy itself. It's already done. And we'll just run a builder with the CW flag. I've kind of hit the details that we build it with the CW flag. On the right here, we have the key broker server running. And if you see, we have client registration, the queries that were for that policy. Also known as the queries, is that is the policy. The data measurement is equal to the input measurement. The reference values, the only reference value we submitted was the expected launch measurement, because that's the only one specified in the policy. And the only retrievable resource is a passphrase to unlock your root disk. And all of this is stored in plain text just for the sake of the demo. But that was all registered. And then like we said, we had that UUID. And then I base64 encoded that so you can put it into the host data portion of the attestation report. You don't need to put it in host data, but it's just a way to parse it. So if host data is used for something else, you can put it in there. But that's the base64 encoded UUID on the right there. And then your container image was then built with all of that in mind. And then we can run it with Podman. We can run it with the krun runtime and specify a name of the server. That's just saying we're running this. It's a web server. Remember, we're running that on port 8080. And then we'll run it confidentially, and we're specifying the container image we want to run. So krun will go ahead and start that. And if we see on the right here, krun reached out for the attestation. The attestation begun. It detected SevSMP, ran the endorser, which checks the certificate chain, finds the UUID I mentioned before, parsed from host data. So it finds that data, then fetches the evidence associated with that ID. And going through the policy itself, it checks each query within that policy. The only one, remember, that we submitted was that the measurements were the same. It checks that, and because the attestation was successful, you can now fetch that passphrase and unlock your root disk. And if you see on the left, the krun runtime says unlocking Lux root file system to begin running, mounts it, and now that's at this point, it's running on the system, this web server. So we'll reach out to the web server with a simple curl request. Remember, that's going to pass Open Sesame. That's just showing that the VM can read its own memory and send that back. And now from the host, we'll use GDB to dump the contents of that process running confidentially. And we'll search for that secret. So if it's not running confidentially, it's in plain text memory, we'll be able to read that secret. And so we just dump the contents into that core dump file, and then we'll grep for the password. And we can't find it because that's running encrypted. You can take my word for it, for the sake of time, that if it were not running encrypted, we would be able to read that passphrase. Sorry, I had to kind of rush there for the sake of time, but I hope I was able to follow it a bit. I also did another talk on YouTube, so. To Daniel's question, we only have one UUID per container image. That's correct. It's basically just an ID to associate in order to map a container image to the reference values it needs to attest with.
Cool. Thanks very much, Tyler. We're out of time now, so there's no time for more questions. But it was a very nice demo. Thanks.
Yeah, if there's anything, I had to go quickly there. If anybody has any questions or whatnot, or I can go through this at a bit slower pace or whatever, you can reach out to me.
Do you want to have a follow-up Q&A session at the next meeting? We can schedule that if you want.
That depends if there's enough people that have questions. If there's interest in it, I'm more than willing to do so. But yeah.
Right. So are you on the CCC Slack instance?
I don't believe so.
Okay, I can send you an invite.
Join it. Yeah, if you can send me an invite, I can join it. And
you can join in, and we can see there if there's enough interest for next time to have you again with us.
Sure.
But you are invited anyway, right? So cool. Thanks very much. I'll follow up with you on for the Slack invite. We have a bit of an admin to do. Who's going to chair the next one? Is Jim or Greg still here?
I think we are. Who is next on the round robin? Was it? I think it might be Keith.
Keith left, so
yeah, I can do it. Just put me down.
Thanks, Jim.
All right.
Awesome. Okay, see you in a couple of weeks and
See you
on the Slack channel. Bye bye.
In a couple of weeks.
Cheers.
Okay, bye.
Thank you. Bye.